Alright, this is about an experimental design for producing clean water out of salt water. And that's particularly important because what we face in the future is a lack of water among so many other things. So, the deal here is that we're going to use heat, as in a desert where most clean water is absolutely necessary, to generate that water. And we're going to do that by bringing in seawater. That would be these pink little pipes here that are coiled around a rising shaft. This is like 200, 300 feet tall. This part up here, and what it does is it heats up, and there will be air that's drawn into the column, and that will turn a little fan here which turns a little pump. And anyway, the water, more correctly, the water comes in through the pipes. It takes a long time to get through the pipes so that it heats up properly. It then goes into a salt trap, which is basically just a pan that will allow salt to collect in it. We're using magnifying lenses here to isolate some heat right here so that we create steam. Steam is important because that's what separates the salt from the water that we can drink. So we have a little ball valve here to keep the salt water from going too far. We need a reservoir here to keep the salt water in the column at a certain height so it cannot go higher and expose the drinking water to salt. So anyway, hot water comes in here. We're going to use some magnifying glasses. Hot water doesn't start to evaporate into a steam until it gets to about 160 degrees or so. The hotter it is, the more steam you get, but we need about 160 degrees. So we're using a simple method of directing sunlight onto a portion of the water to create that steam. Steam is we're going to use a very thin element up along the outside of this column, this rising vapor column, to allow the steam to separate from the water and then enter into a pipe that goes up inside of here, inside the rising column. There's going to be hot air coming through here, and it's going to be steam in the pipe coming up. Then we're going to use an outer shield, an outer pipe that has actual condensate water in it, the fresh water in it, to cool that steam down so that we get condensate. And then it needs a little flow to actually collect in the reservoir here. This reservoir is the bottom anchor of the pillar that goes up. So it's it's all part of the same package, but it is a container. And it will have a pump for pushing up condensate water to surround the vapor so that we can condense it down to drinking water. So these little salt traps will have an outlet on the bottom to collect the salt, and that would have to be done by people. This little apron here that's going to surround the pipe is also going to allow hot air to come in, enter the pipe, and go up by the thermal effects of it. And if we have a curtain around it, we can collect a greater amount of air to go up. That air is moving upward, and it will spin a little impeller here that's basically on a shaft that then turns the pump, and it can turn a generator for a little of electric usage, depending on just how much is available for that. So that's the basic reality of it. You got a 200-foot or maybe more large column that sits on a reservoir. That is its anchor that keeps the column straight. We have cool water here, or cooler water than what we're generating here, because the ground is going to provide some cooling for that. And in general, we can actually cool it by creating air from the nightfall. If we wanted to pump cold water into that, we could. Anyway, so the deal is you take some hot salt water and use a reservoir to control the height of the column. so that, you know, it will spill out of the reservoir instead of spilling out of the top of our pipes here in case something goes wrong and water just ends up here instead of vapor. We cannot have that. So the salt water comes in, gets heated up in a lengthy coil that surrounds the thing. It then enters the salt traps, miscellaneous ones here, individual ones, where it is magnified a little bit more, turns into vapor. Little holes along the sides here allow vapor to enter into the pipe that's inside the chamber here, and condensating water is circulating that pipe, so that from this reservoir, so that it will drain out from the little drain holes back into the reservoir as it fills up. So that's the basic plan. It's not hard, it's not complicated, it's a little expensive to build, but once it's built, it will remain there for you know, as long as it doesn't fall over. So you know, you need a little overflow on that, and there are some miscellaneous other things to it, but you have to start somewhere, and that's where you're going to start. Anyway, gives you a little better idea of what it is.